and in this video we are going to solve challenge 1. And challenge 1 is to decode the message ZET We are given two letters of the original message. The third letter of the message, which also happens to be the third letter of the alphabet, is C, and the other letter that we are given is O, which is the 15th letter of the alphabet. So the two letters that we are given, C and O, are 12 letters apart in the alphabet, and that comes from the decoded message. So therefore the decoded spacing, which we're calling dspace, is 12. Now we can see that C from the original message is encoded to T, and O from the original message is encoded to F. So let's have a look at those two letters, T and F. Now T is the 20th letter of the alphabet, and F is the 6th letter of the alphabet. However, as F is before T in the alphabet, we're going to add 26 to 6 and therefore treat F as being the 32nd letter of the alphabet. So 32, the position of F, minus 20, the position of T, is 12, so that those two letters are 12 letters apart. F is 12 letters after T in the alphabet, and that is in the encoded message. So N space, the encoded spacing, is 12. We then need to work out N space divided by D space. Both of those are 12, so when we do that division we get 1, which is a whole number, and that is our multiplier. So while we've got a multiplier of 1, so we could skip the step, but in general, if you had a different multiplier, you would need to use the multiplier partner table that you see on screen there to work out what the partner is and what you would need to multiply by to undo the multiplier. So we have worked out, now let's find the number that was added. So C is the third letter of the alphabet. We now know that the multiplier used is 1, so we need to work out 1 times 3, which is 3. Divide that by 26, the number of letters in the alphabet. The remainder is clearly 3, and that corresponds to the letter C. Now, you need to go forward 17 letters in the alphabet to get to T, which is the 20th letter of the alphabet. So therefore, the number that's added is 17, and therefore our Caesar shift is 17. We could have also used O instead. Now O is the 15th letter of the alphabet. We already know that the multiplier used in decoding the message is 1, so we work out 1 times 15, and that is 15. And we divide 15 by 26, which gives us 15 corresponding to O. You then need to go forward 17 letters in the alphabet to get to F. So if we go 17 letters in the alphabet forward from O, and once we get to Z, we wrap around back to A. So 17 letters from O gets us to F. Now, in the first row of numbers, we've replaced each letter with the position in the alphabet. So Z is the 26th letter of the alphabet, E is the 5th letter of the alphabet, and so on, to get the first row of numbers that we will need to decode the message. Now, the number added is 17. We've already worked out from the previous two slides that the Caesar shift is 17, and that Caesar shift used when encoding the message can be undone by a further Caesar shift of 26 minus 17, which is 9. So To get the second row of numbers, we are going to add 9 to the first row of numbers. 26 plus 9 is 35, 5 plus 9 is 14, 20 plus 9 is 29, and so on and so on. So the next thing to do would be to multiply by the partner, which we know to be 1, to get the third row of numbers. So the partner we got from the multiplier partner table previously, and to get the third row we multiplied the second row by 1, which obviously didn't change anything, as multiplying by 1 never changes anything. And from there we would need to take the remainder when we divide by 26. So the fourth row of numbers there is the remainder when we divide by 26, and if there are any zeros that appear in that fourth row, we need to replace them with 26. And then once we've done that, what we need to do is replace each number in that fourth row with that letter in the alphabet. So the 9th letter of the alphabet is I, the 14th letter of the alphabet is N, and so on. And once you've done that, what you get is the original message, which is inception. And that is what challenge number 1 is. It is the inception of the Aficionado challenge. Happy aficionadoing, and see you for the next video.